Hello everyone. I guess that I'm live. Good evening, Neha. If I'm properly audible to you people, you can give a thumbs up in the comment section. Good evening. If I'm properly audible to you people, you can give a thumbs up in the comment section. Let's wait for a few minutes so that everyone can join. In the meanwhile, you can tell me from which university or college you guys are from. You people can comment the name of your university or college in the comment section. Good evening, Tamil Selvi. If you people have any doubt related to the topics that we covered in the last class, you can ask now. If you people have any doubt related to the topics that we covered in previous sessions, you can ask now. I believe no doubts. So let me ask you a question then. Why do we need more data for building any model in machine learning? We can make the model using a less amount of data too. Why do we need more data? Good evening, Vaishnavi. Okay, so Neha is from JT Mahajan College. Any guess why do we use more data for making any model? Okay, Neha. Good evening, Rutresh. Good evening, Praveen. Okay, so someone is from Mithibai College. Good evening, Manvendra. Yes, for better accuracy. Correct answer. So next question. Yeah. HF zone, yes, for better results, which will give us the better accuracy of the model. So next question, as we learned or understood how to plot graphs using matplotlib library. So if we want to give some title to a graph, what do we write for giving the title to the graph? Good evening, Komal. Good evening, Reshma. So what do we write for giving a title to the graph? What is that single line of code in matplotlib library? Any guesses? Good evening, Vikas. We'll start at 7:10. Till then, you answer the question that I asked. Let us wait for a few more people to join. If you guys have any doubts related to the sessions that we had earlier, you can ask now. Any guesses? Yes, you are right. You have to use title function from matplotlib.pyplot. Yes. So last question for today from my side is difference between supervised and unsupervised learning. Difference between supervised and unsupervised machine learning. Yes, HF zone. We use plt.title. And one thing here in the function title, you're passing a string, I believe. So you'll have to mention the string in quotations, either single ones or double ones. Otherwise, it will throw an error. The last question from my side. Difference between supervised and unsupervised learning. Just in 2-3 words. Any guesses? Yes, you are correct now. plt.title. Then the string. Yes, the correct answer. So in supervised, you have labels, which can be used for prediction. And the opposite of it, we don't have any labels in unsupervised. Yes, in unsupervised, you do not have labels, and it is basically used for classification. Yes, Komal, labeled in supervised machine learning. So let us start with today's class. So yesterday we covered linear regression. It's one example in Google Colab. So let me discuss another example for linear regression. Is my screen properly visible to you people? Should I zoom in or it is properly visible? Okay, Vaishnavi. So let us start with linear regression. So we already covered all this. So this is another example in the form of screenshots. You can see that again importing the important libraries at the start, then using the CSV file, reading the CSV file that we want to use. So this is the CSV file we have. We have GRE score or university rating, CGPA and all. And on the basis of this, we'll be predicting the chance of admission. So using this data set only, you can get that chance of admission depends on all these factors or all these scores and a CGPA, that is our marks and all. So we will be given the dependent variable. We will be taking chance of admit or chance of admission, you can say, and other are the independent factors. Reason being, your particular score does not depend on the another one. Like you will be giving different exams, so one examination is not related to the other one. So that's why other things are independent. So again, for dividing a data set into 4 parts, training part and testing part. We'll be doing that using sklearn.model selection library. We'll be importing train test split and passing the independent and dependent variables that we have separated. Again, test size you can decide. For this, I've taken test size as 10% and the other 90% will be going for training part of the machine, of the model. Now here I have imported linear regression. I'm giving it in the form of, I'm making an object of it in LNR. So using lnr.fit, I'm passing x train and y train. That means that I'm passing independent and dependent variables. That this, if we have this score, we'll be getting this percentage for chance of admission. Again, this is to find out the slope and this is to find out the intercept that we already discussed yesterday. Now to predict, we're going to use lnr.predict function and we'll be using the testing data set. And this is to find the errors, mean absolute error or mean squared error or root mean squared error. Next, so this is used for plotting the graph. Both the things I've plotted in scatter form. So the predicted ones are green colored and the testing ones are that we already had as an answer are red ones. So let's see the graph. So you can see they are somewhat close to each other, that it is making some accurate predictions also. The green ones are the prediction values and the red ones are the values that we already had. So this was about linear regression that we already studied yesterday. If you people have any doubt in linear regression, you can ask now. It is giving us a linear kind of scatter plot. If you people have any doubts in linear regression, you can ask now. Is it clear till here? Is everything clear about linear regression? I believe no doubts. So next, we already covered the introduction to machine learning. we covered these two types, supervised and unsupervised, and we also implemented one algorithm under supervised, that is linear regression. Now we'll be discussing reinforcement learning. Like we discussed in supervised, we have features as well as labels. Let me get to that image once again. Yeah, here you can see we have labels as well as features in supervised machine learning. We'll be passing that to the machine, we'll be testing our data, and we'll be getting predictions. So we can the machine can always understand that it is giving any false prediction or right one, because it already have some labels. But in unsupervised, we studied that we have unlabeled data. So even if machine is giving any wrong result, machine will not be knowing that it is giving us wrong results. So that's what's the difference between reinforcement learning, that basically if it will give us some different predictions. For example, other than circle, if it is giving this shape as the title of rectangle supposedly, so that will be passed on as the feedback to the machine that you have given the wrong answer. Then it will be correcting itself and giving the answer as circle. So this is how reinforcement learning works. It is a feedback based machine learning technique. In this, the machine learns automatically using feedbacks without any label data. This is the same thing that here also we don't have any label data in reinforcement learning, but in unsupervised learning, you don't have any feedback system. But in reinforcement learning, you have feedback system. Supposedly, you are passing on this, let us consider the same example, that you're passing these unlabeled data to the machine, and it is segregating these separate, but it is giving the answer for rectangles as circles. If it is telling us that this shape is circle, but it is wrong, so we will be passing a feedback to the machine that you have given the wrong prediction, so it will correct itself and give us the right answer as rectangle. But if it is already giving us the right answer for hexagon, we will also pass a feedback in this case also, but a positive feedback. For the false answer, we will be passing a negative feedback. For the right answer, we will be passing a positive feedback. So that machine should know that either it is giving us right answer or wrong one. So is it clear for unsupervised learning and supervised and reinforcement learning, that reinforcement is a feedback based machine learning technique? How does this work? Is it clear? No issue, you can watch this video today only. Yes, for yesterday's class you can watch the video today also. It is available on the YouTube channel, and in the description you can find the attendance link too. Any questions related to reinforcement learning? Is everything clear? If you people have any doubts, you can ask now. After this, we will be covering logistic regression and its implementation too. Okay, so I believe it is clear. If anyone else, if anyone have any doubt, so after this we will be moving on to the logistic regression, which is also one of the algorithms that come under supervised machine learning, and then we will be implementing that also. If you people have any doubt in introduction of machine learning or supervised machine learning or unsupervised, you can ask now. Okay, Vikas, no doubts. So next, let us move on to logistic regression. So what is logistic regression? Basically, in logistic regression, you can get only two types of outputs, either true or false. That is either 1 or 0 as the answer. It will be only always giving you the output as either 1 or either 0. So you can see it is actually going from false to true. So you can see this is, if we will be connecting all these dots, it will give us a S-shaped curve. So that's why we call it sigmoid curve. We have only two types of outputs in logistic regression. It is supervised learning algorithm only. So you can have different get different predictions using logistic regression. These are just examples of this, that a particular email, you can say, is a spam or not. There can be either two possibilities only, that either it is spam mail or it is not spam mail. You cannot have any third possibility here. So next, here also you will be having dependent variable and independent variable. So how you will check that what is the dependent variable in logistic regression? Like in for the independent variable, you will be having different values, continuous, discrete, or individual things. But for dependent variable, you will be having answer in 1 or 0, that is true or false, yes or no, high or low, like these, like only two possibilities. This is how you're going to segregate both dependent and independent variable. So is it clear till here for HS? Yes, you can practice all the functions in any Python software. You can use VS Code, you can use Atom, you can use Jupyter Notebook or Google Colab also. All the notebooks in Google Colab are directly saved to your drive. So that will be most easy thing. So I believe. But you can use anything for practicing these functions. You just need to keep an eye on the indentation part properly. That's it. If you have any doubts still here in logistic regression, you can ask now. Is it clear? Okay, I believe it's clear. If you people have no doubts in logistic regression till here, let us move to the next part. This is how you're going to decide the dependent and independent variable. Okay, Karthikeyan. Okay, Dipesh. So again, the same thing. We are connecting the dots here. It is giving us something S-shaped curve. So here we are going from the false values to the true values, from zeros to the 1. Now, what is confusion matrix? Actually, confusion matrix is basically used for checking the type of results we are getting. For example, this is true class, this is predicted class. Here, by true class, we mean that the data we have already have. We'll be testing on that only, so we also know we can compare both the data given by the machine or the data we already had. Okay, Mobin, I'll repeat logistic regression, no issue. So basically, yesterday we saw linear regression in which we were getting a straight line. We had equation y is equals to mx plus c there. We can get any prediction in linear regression. But in logistic, you can have only two types of outputs, either 0 or either 1. So here you are getting 0 values here and 1 values here. If we will be connecting these dots, you will get a S-shaped curve, which is also referred to as sigmoid curve. Here, this is these are just examples where you can implement this algorithm. For example, spam detection or either any of the disease detection, like it can give us answer only in two forms, like either yes or no, that is either 1 or 0. So that's why we can use logistic regression here. So how to find out a dependent and independent variable in the data set? It is like if any variable can be answered only in two forms, either true, false, yes, no, high, low, and so on. There can be many other things here. So that will be dependent variable. But in independent variable, you will see you will be having continuous or discrete values in the data set itself. Then that will be referred to as independent variable. Now next, again the same thing, that if we can see the sigmoid curve, it is actually moving from false values to the true values. S-shaped curve or sigmoid curve. Is it clear till here? Should I start with confusion matrix? Is it clear? Should I start with confusion matrix? What is confusion matrix? I believe it's clear. So we can move to, okay, Mobin. So it's clear to you. So now with confusion matrix, we're gonna check if a model is giving the correct answers or not. Here you can see I already told you, you will be having only two types of uh, answers, either positive or negative, yes, no, true, false, like this only. So here we have positive, negative, then positive, negative. Okay, Vaishnavi. Okay, Neha. So next we have here, like if the predicted answer is coming positive and this our answer given in the data set is also positive, then you can see that number in this, here in this position of the matrix. But if a answer is we are getting positive answer from the prediction, but we already had in the data set as 0, so that means we are getting false prediction. So this index of the matrix will give us that this much results are negative ones, that actually they were negative but the machine is predicting it wrongly. And here again, if the answer was positive, the machine is predicting us a negative answer, and here the answer was also negative and the prediction is also negative, so that's why it is green. So this is how you, using confusion matrix, you can judge the type of answers you're getting from the machine. Is it clear? Is it clear to everyone? So this is how you use a confusion matrix. For the green part, they are giving us the right answers. We are getting positive answer for the positive ones and negative answer for the negative ones. But for the red values, you can see we are getting negative answers. Is it clear? Can we move to the implementation part now? Okay, first. So it's clear. So let's move to the next part. Now implementation part, let us jump to the collab only for the implementation part. So here again, we'll be using some CSV file. So we need to upload it from here using this. Then you can select the CSV file you want to work in. So I've already uploaded that here, health.csv, on which we will be working. So in the first part again, importing, yes. So we'll be importing the libraries like NumPy, then Matplotlib or Pandas. So here then again loading the CSV file that we have, using the read underscore, 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 CSV function. Then again, dividing data into two parts. You can get data printed here also. Let me get my data printed here. So this was my data. So these are different columns that we have, and they depend on different factors, on your height, on your weight, are you healthy or not. So that will and according to the country you are living in, or according to the continent you are living in, it will decide the climatic changes too, and so many different factors. So it will decide that someone will survive till this part or not. So this is the dependent variable, which is 0, 1, 2, 3, which is the third column. So you can see for the y we are considering the dependent part, and for x we are considering the all the independent values. Is it clear that how we have divided the data? Okay, you want me to repeat it again from starting? Okay, I'll do it really fast then. So again, logistic regression. In linear regression, we were getting predicted different kinds of values which were ranging according to the data that we had. But in logistic regression, you can get only two values, which is either 1 or 0, or true or false. This is how it works. So here we have different examples on which you can use a logistic regression algorithm. Reason being, let us take the example of the spam mail again. If we have any email, then you can either categorize it under spam, or you can categorize it under other sections, that is not spam. So here you can either give answer as 1, or either you can give answer as 0. So that's why you can use logistic regression here. Same with the other examples. Then again, how to find out the dependent variable and independent variable. So for dependent variable, we will always be having the answer as true or false or 0, 1, like this only. And in independent variable, you will be having different continuous or discrete values, I should say, in the data set. And this is in logistic regression, we get the S-shaped curve starting from basically starting from false part, 0 part, to the 1 part, that is true. So we also call it sigmoid curve. And for confusion matrix, we are plotting this to check that if our prediction is correct or not. For the green part, you can see we already had data set. In data set we had positive, and the machine is also predicting positive, so that's why it is green. And here in negative, you can see we had answer as negative in the data set, and here also machine is predicting as negative, so we have green here also. But for these two cases, we had negative answer in data set, but we are getting false, so this is wrong. That's why red. So in here also we had answer as positive, but we were getting answer as negative from the machine, from the model. So this is how it works to check the accuracy of your model. Is it clear now? Is it clear, Karthikeyan and Faraz? Is it clear to everyone? Okay, Neha. So next, let us get back to the implementation part. Again, I told you that how to divide a data set into two parts, that is depending part. So here y was the dependent variable that we have to predict. Okay, Rushil. And we have independent as the x part. So yeah, so this is how we divided our data to check we can get both of the things printed, like x also and y also. Let us get it printed. So you can see as we have divided the data, for the y part we are only getting yes and no, which is the dependent variable that we need to get predicted in our case. And for x part we have only these three columns, And again, this is the whole data set that we have. Again, today we are using such a small data set for the logistic regression implementation part. No problem first. Okay. You want the attendance link that I'll be sending you at 7:50, and for the presentations that are shared in the Telegram group itself of edspread. Screen is not clear. Is it not clear, people? Is my screen not visible properly? Yeah, we will be dividing a data set in the upcoming steps in xtrain, xtest, and ytrain, ytest using sklearn library only that we use for linear regression 2. These are just variable names. You can name them according to you. We but name it like this so that we have an idea that it is what kind of variable, what kind of data we have, and where to pass it on. Okay, first, okay, Karthikeyan. So next. Now again, this is used for checking the info of the data frame that we have. Here we have X in the form of data frame. So it is just telling us that it has how many non-null values. So now label encoder. So why we are using label encoder here? Because we want to get a data predicted, but machine always understand numbers. So using label encoder, we're gonna change our data frame a little bit. Like you can see, we have numbers everywhere, but in this column we don't have any numbers. So we will be telling the machine to automatically convert it into the numbers depending on the types of data we have. Like we have 3 types of data, so it will convert them into 0, 1 and 2. It will automatically give them labels. So how to do this? From sklearn.preprocessing, we will be importing label encoder. So again, here we are creating an object of label encoder LB. So for X data frame, again iloc is used for slicing. So we are just telling which column we have to change. Again, we need to change all the rows of that particular column. So we are not passing any index for row, but for column we are passing 0th column. So the column at 0th index will be changed using label encoder. We have to pass that particular column to the fit transform function of label encoder so that we can get it changed. Is it clear to everyone? And for y also, you can use a y label encoder also if we have any values in that particular data frame also. Is it clear to everyone? But in y, we had yes or no as answer, you can see. So we are only getting values as either 0 or 1. So you can see we also used label encoder for y also. So we have printed it here. So we are only getting values as either 1 or 0. So 1 for yes, 0 for no. So I believe it's clear. Okay, Mahir, okay, Roshit. So next. So now we are importing simple imputer. Why do we need it? Actually, you must have seen in the data set that we have some null values here, which will trouble us while predicting the data, getting a data predicted from the machine. So we need to replace this. So using simple imputer, we're gonna replace it. So we are telling the simple imputer that we have the missing values as NaN. You can see null values. So how to replace it? We're gonna mention that it into the strategy. So in strategy, we are telling mean. That means it will take the mean of the whole column, then it will pass that value to the null value. So null will be replaced by the mean of the whole column. You can see height column here, we have null values here in the 7th row. So here in 7th row, we have 180 as answer. And for another one, where we have two null values, like here also we have null value. So for weight, it will take the mean of this weight column and replace it with the mean of this column. So in 4th, you can see it is replaced by the mean value. So again, how to pass it? ms.fit. You can pass those columns that you want to check. Again, same thing, starting from 1 to second column, you're gonna check. Then again, updating the values, like we are passing the values, these values that we predicted using this, we got the mean. So now again, we are passing these values back to the data frame. You can see to those particular columns only. So here using transform, you're gonna change those values. So now the updated data frame that we have is this. We don't have any kind of null values now. Is it clear to everyone? If you people have any doubts, you can ask now. Then if we have more than one null values in the column, then all those null values will be replaced by mean. It doesn't matter if we have 1, 2 or many null values. Like it depends on the strategy what you are passing on. Like I passed mean, so it will take mean of the whole column, then it will search for the null values, then we're gonna change the data frame. That is, we will be replacing the null values using simple imputer only from the mean of the column. Should we move to the next part? Is it clear? If it is clear to everyone, you can tell in the comment section so that we can move to the next part. Okay, Roshil. So next, now we have processed a data set using the libraries, different libraries. Now we're gonna divide a data set into xtrain, xtest, ytrain, ytest. Okay, Kritika. So next, using sklearn model, sklearn.model underscore selection only, we're gonna import train test split. Similar to this, we already did this in linear regression also. So we have these 4 variables that we will be using. So in train test split, we are passing the independent data and then dependent data, then test size as 0.2, then random state as 0. It up to us what we want to pass in these two parameters. So here by test size, it means in test size we will be having 20% of the data, but for the train size we will be having the 80% of the data. We are having 80-20 approach here. You can have anything here. So after that, we got a X train printed. So now we have these random values in a X train part that we will be using for prediction. Okay, Neha, first how to get mean value. So we already passed this in this strategy that we want mean. So it will be done automatically, handled by the simple imputer. You don't need to worry about it. You just need to tell the columns on which you want to perform this particular the particular changes. Then you need to update those values using mss.transform. You can use any variable here instead of mss. It's up to you. So next, we have divided the data set into 4 parts. Now we're gonna implement a logistic regression. So again, importing the logistic regression from sklearn.linear model. Like yesterday we imported linear regression. So in the similar way, you have to import the logistic regression. Then again, I am making a object of logistic regression. So LR classifier. So now I am passing my training data to the model to get trained. So using dot fit, you always train your model. Whenever you see dot fit something, that means you're training, you're passing the data to train the model. So now we have passed the data. Now we want predictions from the model. So using dot predict, you can get predictions, but I'm passing x test that I want to check the value also. So let me comment out this part for now. So if we will run it, oh, I have not printed. Okay, so let me run it from the starting. I think I forgot to run one cell. Yeah, 1 second. Yeah, okay, I forgot to run one cell. That's why some of the values were not updated. So now no error. So I forgot to get it printed. Let me print the prediction. So as prediction, I'm getting this array 0 1 1 0. So to check the accuracy of the model, you need to import accuracy underscore score. So for accuracy, you have to pass the testing one, and you also have to pass the prediction value to check the accuracy score. So you can see the accuracy score we are getting as 1.0, which means we are having 100% accuracy here. In this case, we are having 100% accuracy. So for next part, confusion matrix, as I told you people. So let me comment out this part. So this is the confusion matrix. So this for the first part we have positive here. That means for the positive values we are getting positive as answer, and for the negative values we are getting negative as answer, and we are not getting any wrong answer from here. So that's why we have 0 0 in this case. So let me get printed the y test. So as y test we had 1 0, and for the prediction, what do we have? Given y. Let me rename it to given y, and let me rename it to predicted y. So let me run it again. So you can see for the given also we had 1 0 in the data set, and prediction values are also 1 0. So this is how it works. So you can see we have this model of logistic regression with 100% accuracy. So if you people have any doubts, you can ask now. If you people have any doubts, you can ask now. Okay, so attendance link, I will be sharing the attendance link at 7:50. Till then, you can tell me if you have any doubts in logistic regression. If you want me to repeat any particular part, you can tell me. If you have any doubt in logistic regressions implementation, you can ask now. If you have doubt in any particular topic, we can also use PPT to explain you. Once again, no issue in that. Okay, Mahir, it's clear. If you people have any doubt, you can ask. So let me share the attendance link with you people. Okay, Vishnu, this is the attendance link, and I'm sharing my Twitter handle with you people. If you want to connect with me, you can connect with me on Twitter. And moreover, if you guys like all these sessions, all these boot camps going on, you can like all the videos. You can subscribe to edspread. And yesterday also I told you, if you have any doubts till the previous topics, you can ask me in today's class. If you have any doubts, you can ask now in any of the machine learning algorithms. From next class, we'll start implementing the project. I've shared the attendance link in the comment section. If you people have any doubts, you can ask now. Okay, if you guys have no doubts, so let me ask you a simple question that you people must be using any Netflix or any Amazon Prime for watching any movies or web series. So what do you think that Netflix recommendation tool works on which method, which learning method? Supervised machine learning, unsupervised, or reinforcement? Like you must have seen that uh, once you uh, see particular movie or web series, it starts giving you recommendations on the basis of what you saw. So what do you think? Okay, first. So what do you think the Netflix recommendation tool is based on? Supervised or unsupervised? Any guesses? Okay, Neha, no doubts. So any guesses that it has unsupervised learning or supervised or reinforcement? Okay, Mobin, I'll explain you about confusion matrix once again. Uh, Let us know the answer of the question that I asked. Any guesses? You don't have to be right, but you can guess at least. Unsupervised. Okay, Manvendra. Okay, Mahir. So, any more guesses? So basically, Netflix movie recommendation is based on supervised machine learning because it starts okay, because unsupervised, but it is based on supervised machine learning. Reason being, when we search for any particular movie, it takes that movie as the data, all the attributes of that movie, then it recommends us on the basis of that. Either you are watching a thriller movie or different attributes of the movie, so it is considered under supervised machine learning. So is it clear? Is it clear to you people? Is it clear to you people? Is it clear? It is based on the previous inputs. Yes, yes, Yuvraj. Inputs get labeled and then it is used for supervised machine learning algorithms in Netflix and any other. Okay, Rushil. So someone was asking me confusion matrix once again. Let me repeat it. Rushil, for one hot encoding part, actually you will have to, that is different kind of machine learning. Like you have digital circuits, you must have seen. We have different bits in that. Uh, for high bit you use 1 and for lower one you use 0. So it is considered under that, but we are not gonna go into the detail of one hot encoding method. Actually, this method is basically used for converting the data so that we can use it for particular algorithm to get a particular prediction by assigning the values as 0 or 1. So that is something you're going to learn if you, after this bootcamp, if you deep dive into machine learning. So for the confusion matrix, so basically in confusion matrix you use this to check the accuracy of the model only. Like here for green part you can see we are getting the right values. For the green part you are getting the right values. That means in dataset also we had positive as answer, and the machine is also predicting it to be positive. And here you can see that in dataset we had negative as answer, and here also we are getting a data predicted in the form of negative only. So you can see these are green, but here you can see the false predictions of the machine in the red part. Like if the answer is negative, the machine is giving it to be positive, and here if the answer is positive, the machine is giving it to be negative. Is it clear? Is it clear how much confusion matrix works? Here also you can see we got our own confusion matrix printed. So here you can see 1 is given for the values that we are getting right as answer for the predicted right predicted part, but we had 100% accuracy, so our model didn't predicted any wrong value. So that's why we have 0 here in both uh, false predictions part. Again you can consider this thing, like you can see a data that we were using here. So we have just these values, just I guess 9 values. So yeah, starting from 0 to 8, so we had 9 values. Again we are using a small data set here. Again, if you want a very good model, you have to use a large data set. So again, that thing, more the data, more the better the model, and then we can gonna get a good accuracy of the model and all the predictions. Okay, Movin. So this was all from my side. If you people have any doubts, you can ask. And thank you so much for being a patient listener. If you people have any doubts, you can ask now. This was all from my side. Let me share the attendance link again with you people. And if you people are liking all these boot camps and these classes, do like and subscribe edspread. I've shared the attendance link once again in the chat. Is everything clear? Is everything clear? For batch gradient and Newton's gradient descent, that you will get to know tomorrow only in tomorrow's class, that what method we're gonna use in project. So we're gonna build the stock prediction model, but it will be a very basic model according to the bootcamp, because we are having people from with zero knowledge of Python, so they have started this bootcamp. Uh, by that reason only. So I believe we should keep it basic only to build the project. So we will be building a stock prediction model using linear regression. So I want you people to revise linear regression for the next class. Yes, Karthikeyan, you can see all these sessions again on the edspread's YouTube channel. And so that was from my side. Let us connect tomorrow. So bye bye. Thank you. Bye everyone.